Have you ever looked up at the beautiful glowing moon on a clear night and wondered how it creates that magical light? Does the moon have some kind of built-in flashlight, or is there something else going on up there? Today, we're going to solve one of the biggest mysteries about our night sky and discover the amazing truth about moonlight. You might be shocked to learn that the moon is playing a clever trick on us, and by the end of this video, you'll never look at the moon the same way again. Get ready to uncover the secret behind the moon's mysterious glow. Here's something that might blow your mind. The moon doesn't actually create its own light at all. Just like a mirror in your bathroom reflects your face back to you, the moon acts like a massive mirror floating in space that bounces the sun's light toward Earth. The moon is really just a big, gray, dusty rock with no light bulbs, fire, or any kind of power source inside it. When bright sunlight hits the moon's rocky surface during the day or night, that surface reflects the light back out into space in all directions. Some of that reflected sunlight travels the 240,000 miles back to Earth, which is what we see as beautiful, glowing moonlight in our night sky. Every single ray of moonlight that reaches your eyes is actually sunlight that is bounced off the moon's surface. It's like the moon is playing the ultimate game of cosmic catch with the sun. The sun constantly shoots out billions of light rays in every direction, and when these rays hit the moon, they get reflected back toward us just like light bouncing off a white wall. This means that romantic moonlit walks and spooky nighttime shadows are all created by the same star that gives us daylight, the sun. The light looks different because it's much weaker after traveling such vast distances and bouncing off the dusty lunar surface. Think of it as sunlight that took the scenic route to get to Earth. The moon's surface is covered in a thick layer of fine dust and millions of tiny rock particles that make it perfect for reflecting light, kind of like cosmic sandpaper or a giant piece of gray chalk. This lunar dust was created over billions of years as meteorites and space rocks crashed into the moon, grinding up the surface into powder. When sunlight hits all these tiny dust particles in rough rocky areas, the light bounces off in many different directions, scattering back toward Earth. The moon's surface is actually quite dark, about as dark as charcoal or black asphalt, but it still reflects enough sunlight to create the beautiful glow we see. If the moon's surface was smooth like a perfect mirror, we'd only see a tiny bright spot instead of the full glowing disk. The reason the moon appears to change shape throughout the month is all about how much of its sunlit side we can see from Earth, like watching someone slowly turn a flashlight lit ball in a dark room. As the moon orbits around Earth every 29.5 days, we see different amounts of the side that's being lit up by the sun. During a new moon, the lit side faces completely away from us, so we can't see any reflected light at all. During a full moon, we can see the entire sunlit side, which reflects the maximum amount of light back to Earth, making it super bright and beautiful. The crescent and quarter moon phases happen when we can only see part of the moon's lit side, so only that visible portion reflects sunlight back to us. Even though the moon can light up the entire night sky, moonlight is actually incredibly weak compared to direct sunlight, about 400,000 times dimmer. This happens because the moon only reflects about 12% of the sunlight that hits it, and then that reflected light has to travel another 240,000 miles through space to reach Earth. By the time moonlight reaches your eyes, it's lost most of its power and energy from the long journey and the bouncing process. This is why you can stare directly at the full moon without hurting your eyes, but you should never look directly at the sun. It's also why moonlight creates such soft, gentle shadows compared to the sharp, dark shadows created by bright sunlight during the day. Not all moon phases reflect the same amount of light back to Earth, which is why some nights are much brighter than others even when the sky is clear. A full moon can reflect so much sunlight that you can actually read a book outside or see colors in a garden, while a crescent moon provides just barely enough light to see basic shapes and shadows. The brightness also depends on how close the moon is to Earth during its slightly oval-shaped orbit. When it's closer, the reflected light appears brighter and stronger. During a lunar eclipse, Earth's shadow blocks the sunlight from reaching the moon, so there's almost no light to reflect, and the moon appears dark red or completely disappears. This proves that the moon truly depends on the sun for all of its light, because when that sunlight gets blocked, the moon's glow vanishes too. Believe it or not, smart people figured out that the moon reflects sunlight over 2,000 years ago, long before we had telescopes, space travel, or modern science. Ancient Greek philosophers like Anaxagoras observed the moon carefully and noticed that lunar eclipses happen when Earth's shadow blocks sunlight from reaching the moon. They also realized that the moon phases always showed the same pattern and timing, which helped them understand that the moon was reflecting light rather than creating it. These ancient astronomers used simple observation and logical thinking to solve the mystery of moonlight, proving that you don't need fancy equipment to make incredible scientific discoveries. Their curiosity about the night sky led to one of humanity's first major breakthroughs in understanding how our solar system works. Now that you know the moon is basically a giant space mirror, what do you think would happen to our nights if the moon suddenly disappeared? Would Earth be completely dark, or would we still have some light? Share your thoughts in the comments below.